Let's start. Hello and welcome to the 9th in our series of GSMA Showcase live events. Firstly, I'd like to thank you for taking the time out of your busy schedules and for joining us here today. I'm very pleased to welcome representatives from across the world who shall be presenting in this session, and obviously the audience are from Lebanon, Malaysia and beyond. For those who don't know me, my name is Conor Dempsey from GSMA Services, and my primary role is to ensure our customers, partners and members are leveraging the full suite of services available to help the mobile industry as a whole. We have a great session ahead of us, which is focused on demonstrating how the police, government and regulatory bodies are utilising GSMA services to help fight crime and reduce fraud. We have some wonderful speakers who are going to share their insights, their best practices and latest market statistics, plus provide real life use cases of how device information is so valuable to them. As a result, we have an action-packed agenda with each session lasting approximately 10 minutes. The first session is from Tyler Smith, Product Director from GSMA Services, who's going to explain how device identification can help across multiple use cases. After which, I'm delighted to say we have Numan Khalid, Director from Pakistan Telecom Authority Regulators, who shall explain how their national policy has significantly reduced counterfeit devices utilising GSMA's tech database. Then Tyler shall explain how GSMA have new attributes within existing services designed specifically to help fight crime. Last but no means least, we have Christian Dresler, Senior Expert Mobility Security from Zitis, who shall provide real-life examples of how GSMA device database helps with criminal investigations. At the end, we will have a Q&A and there will be plenty of time to address and answer as many questions as possible. So just to make you aware that this session is being recorded. With that, I'd ask you not to be shy, put your questions in the right-hand chat and we will address them at the end. So please, for the next 55 minutes, try to resist the temptation to do your emails, use your phone or even do your shopping. So please do listen, do get involved and do ask questions. To kick things off, I would also ask you to participate in our poll questionnaires throughout the session. With that, I'd like to hand over to Tyler from GSMA Services. Tyler, over to you, sir.
Thanks, Connor, and good morning, good evening, good afternoon, since we've got a large crowd from across the world. Hope everyone's doing well, and I just really appreciate the time that you've carved out for us today. So what I'm going to do to kind of kick things off today is really discuss, where this device data comes from and why it's so valuable and important to be utilized across the world for all the different scenarios that we're going to walk through. So just a little background to start with is, we get all of our data on mobile devices from the process of us being the global decimal administrator for over 30 plus years. And what that means is we're responsible for carrying out the tax scheme, i.e. the IMEI allocation schemes globally. Since its inception, we have over 200,000, we've issued over 200,000 plus codes, which is type allocation code, which is the TAC or the first 8 digits of an IMEI. And our data currently covers over 8 billion devices, unique devices. The information we cover and we keep data on from a device perspective is anything that connects or has the ability to connect to a mobile wireless network. So if it has the ability to connect to a mobile network, it has to get a TAC, or it should be getting a TAC from the GSMA or one of our authorized reporting bodies. This covers everything from your standard featured mobile phones, tablets, smartphones, all the way to IoT devices and wearables, modems, wireless gateways, etc. And some of the information that we capture through this process, which is the building block of all of our device information services, are things such as the device model, make and model name, what are the network protocols it supports, or the frequencies, what type of device is it, what are the operating systems, does it have NFC support, how many IMEIs should be on that device, or how many physical SIM slots are on that device. So there's a lot of information available that can really help companies across the ecosystem properly identify and verify devices to avoid issues with counterfeit or an invalid tag. Next slide, please. So we have two variants of our services as it relates to our device information, or our device or mobile device information. So we have really our core service, which is called GSMA Device Database. And with the propensity of devices being launched so frequently, we have about 10,000 new device models launched every year. It's usually more than that, but on average, we'll have over 10,000 new models added into the database every year, which means there's a lot of data being changed daily. And we'll get to that later on in my presentation on how we deliver this information. But we are considered the source of truth when it comes to mobile device information. There are other entities that can claim, or other places that have data, but we get the data directly from the device manufacturers at the point of when they have to be getting a TAC in order to generate their unique IMEIs for those end devices. Then, so device database has about 24 to 26 attributes and covers your basic device details. Then we have our service, which is called GSMA Device Map. Now, GSMA Device Map takes device database and it expands upon that exponentially, in that there's now go from 26 data points to over 150 data points. You can further dig into devices, particularly in the IoT space, to try and determine exactly what is the sole purpose of this device. Is this device going to be utilized for, enabling other devices, or is this device truly the single point and it's going to be contacting and needs, let's say it's an alarm, right? And it needs to have certain, connectivity profiles set to it. The other thing is that in device map, we increase the information as it relates to things such as the chipset that's included in it. Being able to say, all right, the chipset and this one's a MediaTek, or this is a Acme chipset model XYZ. All that information is included in this greater package of our service. Next slide. So how do government entities benefit from our device information data? So we typically look at this as stakeholders on the left-hand side of the screen, which include, obviously we don't exclude anyone, but typically what we see the use cases are with customs, the law enforcement or police agencies, regulators, public policy investigations or public policy analysis, and national law institutes. And typically, and you'll hear more about this from Noman and from Zetas, that these are some of the typical use cases, but there could be more. But this is what we typically see. Being able to validate that the device information you have, right? So say it's in a custom situation, and they presented you with a device, or you're looking at a device, and you want to be able to verify that device is accurate. Then you could use our database service and access that information and compare the two to make sure that the information you're getting is correct. And if it's not, then you can take the necessary actions. You want to make sure that the devices that you're using, or perhaps in public policy spaces or customs or law enforcement or other national law institutes, are using it to determine if, is this device going to be compliant with global standards, and is it a legitimate TAC, right? Has this been done the correct way? Obviously, we'll hear more about the homologation scheme, so I won't get into that. Customs assessments, and then also the identification, what is this device really being used for that's coming into our country? Or what is, if I'm doing an investigation from a police perspective, I get a device, I don't know what this is, I might be able to use these services to go, oh, well, here's a TAC, I can look it up and see that this is a mobile wireless gateway, or this is some type of a wearable that actually connects to the internet through the mobile wireless network. So there's a lot of ways that this can be utilized and benefit government entities. Next slide. So another big question we get, and I wanted to make sure we covered today, is how are these services delivered? How can we ingest this information? So we have a couple of different ways, and we're going to actually be increasing those ways, hopefully by the end of this year, first of next year, to make it even easier for people to gain access to our data. Currently, what we offer is a secure endpoint connection, similar to an SFTP, but you're given a unique secure URL that you can connect to. You get a license key, etc. Then you set up your profile, and your profile, what I mean by profile is you have the ability to just select what data you want and how often you want it. You can get the data and the updates as often as a daily update. And you can also select to do Delta reporting, so that, let's say I only want to get it once a week, but I want to get, whatever's changed or been added since the previous report was downloaded. And that's delivered in two formats. One is a .txt type file, flat file, and the other one is in a .json format. The other way you can gain access is through a general web portal. And this is very, very low tech, right? So you create an account with us, you have a username and a login, you go in, you type in the tag that you're wanting to query, and it returns the results for that one tag. So it's a one-by-one checking solution. We're in the process currently of scoping a full API, a real-time API actually, to be able to deliver a more closely or tighter and faster service delivery that it's easier to implement internally with our end users, right? So that you can take that and go ahead and more easily streamline that integration into what you're already doing currently. So please be on the lookout and listen for the more details around that. The other thing I did want to call out is if you ever do come across any invalid or non-compliant TAC, there is a process to report that to us, and we want you to tell us about these issues that you may run across, or even if you ever have questions. And we have a process built specifically for that called the TAC challenge process. Another way you can report it, obviously, if you ever have any questions, is to reach out to us through the IMEI help desk at GSMA.com, and they will always be happy to get you to the right people internally to help address any of those issues. So yeah, I think this is a great place to end on my side, and then hand it over to the PTA and Naman to tell us how they have used the device database for many years now, or several years now, to help address some issues in their market, specifically in Pakistan.
Thank you, Tyler. Hello, everyone. Good morning, good afternoon, and good evening, based on where you are. My name is Naman Khaled. I am from Pakistan. I am Director Type Approvals at Pakistan Telecommunication Authority. I've been working with PTA for almost 8 years. Prior to that, I have worked globally. I've worked in US market. I worked in Africa market. I would like to talk about how PTA in Pakistan has implemented the GSMA Global TAC database and how it has benefited us. We have been using the GSMA TAC database since 2004, but we have totally revolutionized the use of this since 2019. Just to give you a background, Pakistan is the first country in the world where we have implemented a device identification registration blocking system. It is a nationwide system implemented whereby it's working on the concept of a centralized EIR system. The way we are handling this system is that it is connected with all the local mobile operators. It is connected with the manufacturers. It is connected with the customs authority. It is also utilizing the GSMA TAC database, which we are downloading and utilizing on a daily basis. Jumping to the presentation, let me talk about there's a big, at least before implementing this DERB system, I was not very clear about how to distinguish between a clone device and a duplicate device versus a non-standard device. Clone device, in technical terms, is a device which is programmed with an IMEI. often what we have found is that in a clone device, people would clone a device whereby they would use a lower category handset, for example, a 2G handset, and program that on a smartphone or a 4G handset and try to utilize that. So a fake replica device program with a low-end IMEI. So cloning is where an IMEI has been taken out from one device and programmed on a higher version of device. Duplicated devices are such devices where an IMEI has been programmed on more than one device and it is operating on a local network. Lastly, the non-standard devices are those devices where they are programmed with IMEIs which are not registered within the GSMA tag database. Next slide, please. I have tried to, it's a little extensive slide, but I would I would summarize this, how cloning works in Pakistan and how we are identifying this. The way we are doing it is, first of all, we are getting the real-time database. Our device identification system is connected with the mobile operators, and they are uploading their IMEI databases on for all the active IMEI users on their networks. So immediately, as soon as the data dumps are uploaded into the DERB system, they are cross-checked against the GSMA database to make sure that the IMEIs that are connected belong to the GSMA tag database. If an IMEI does not belong to that, it is immediately identified as a non-standard or non-GSMA data, non-GSMA tag database IMEI. And immediately such devices, the users get an SMS through their respective mobile operator that your device is a replica or a non-standard device, and it will be blocked on the network within 24 hours. So this is one way of how we have mitigated the non-standard devices. Now, in cloning case, there is a very interesting parameter. I'm sure a lot of you who are working in the telco sector may be aware of it. It is called radio access technology. So PTA has utilized this particular parameter and cross-mapped it with the GSMA tag database to identify the clone devices that are operating on our networks. The way it works is that, for example, if you have a device, if I get a replica iPhone or a Samsung device and I program it with a 2G device, the RAT access database is going to inform me that the RAT access radio access technology parameter is going to inform me that this is a device which is, as per GSMA database, is a 2G device, but it is requesting services and utilizing services for a 4G device. So immediately our system identifies such IMEIs. And then what we do is that we cross-check from the GSMA tag database. If you look at the tag database, it is a very rich database which offers a lot of different parameters. One of the key parameters that we have been utilizing is the type of frequencies that the manufacturer declares at the time of registration of a GSMA tag. So we cross-check the GSMA tag with the radio access technology parameter, and we're able to identify that this is a clone device. In such cases, the GSMA RAT based identified IMEIs are segregated in our system. And upon that, we correlate with the GSMA and the mobile operators database. And as an output, we send an SMS to such users. We identify that you're a victim of a clone device. And if you feel that it is a miscalculation, you can send certain parameters where we ask them to send the first IMEI, the second IMEI, and the serial number of the device, so we can cross-check with the manufacturer. So by doing this, we've implemented DERB since 2019. Pakistan is a market of 192 million subscribers, where when we connected the mobile operator database, we have a database of over 600 million IMEIs within Pakistan, out of which, when we started this project, since 2019 till now, we have identified over 29 million cloned devices in our network that were successfully blocked. So by doing this, we have been able to improve the quality of network, the QoS parameters. The operators have reported that since removal of such cloned devices from their networks, it has greatly improved the quality of service parameters. The RF environment has improved significantly. Secondly, from the consumer point of view, now the consumers are well aware of it, where they know that such cloned devices are immediately being detected on the local networks within Pakistan, and they try not to get those devices. So it has mitigated such entities who are trying to clone devices. Next slide, please. As I stated before, duplication of an IMEI is when an IMEI exists on more than one device. And in such cases, the way we are doing it is that we have an algorithm where it runs on all mobile operators. And if an IMEI is seen on a mobile operator more than once in a day at different time frames, so if the frequency of such IMEI appearance with a different mobile number or MSISDN number is greater than 2.5 in 30 days, those IMEIs are identified as duplicated devices. As soon as those devices are identified as duplicated, our system sends an SMS to all such users stating that your device has been identified as a duplicate. If you feel that you are an owner of a genuine device, please send the following parameters where we have multiple mediums available to such users. They can SMS those parameters to us. They can email it to us. We have an online portal where through our complaint management system, they can report these things. So the parameters that we ask from the users are the first IMEI of the device, the second IMEI of device, serial number of the device, and the color of device. So what we do after that is we have through GSMA connected with all the manufacturers, and we have access to their databases as well. So on real-time basis, we transmit the user provided information with the with the manufacturer whose device has been duplicated. To highlight over here, it is easy to duplicate an IMEI, but not the people who are entities who are duplicating such IMEIs do not have the information what is the second IMEI that was programmed by the manufacturer, or the serial number of the device, or what was the color of device that the manufacturer has programmed this genuine IMEI. So by doing this, the manufacturers, we have aligned with them and we have connectivity through an API setup. And through that, they are able to inform us the genuine device IMEI1, IMEI2, color and serial of device. So on average, so as soon as this information is identified, we have come up with a pairing mechanism whereby we pair the IMEI of the genuine device with the MSISDN of that device, and we allow that device to go through to the networks, whereas all the other duplicated devices are blocked. Till date, we have blocked over about 3 million IMEIs on our local network. So in total, the efforts of both cloning and duplication, we have blocked about 32 million IMEIs out of 500 million IMEIs. So just imagine that if you can clean the network by using these techniques, and it all is done because of this wonderful GSMA tag database that we have. And by utilizing all the parameters and the information that is built in there, we have created a very vibrant system that is implemented nationwide, addressing both counterfeit devices that come from duplication and cloning. Next slide, please. I'm sure that everybody is aware of what is the GSMA database, but I've just put in over there that GSMA database provides us with a detailed information where we are getting information such as the type of device, what kind of frequencies are programmed in that device. Another feature that a lot of people might have not used before, I believe that since 2015 onwards, GSMA has mandated the manufacturers to also put the total number of SIM slots or the IMEI slots that are there. So we are also utilizing that parameter where we ask all our devices that are connected at the time they are required to register such devices. So in case of devices that offer more than one IMEIs, we cross-check that data from the GSMA tag database and immediately inform the user that the device that you are about to register is programmed with 2 IMEIs. I'll give you a very real-time use case of this. So in case of Apple, when Apple launched their iPhone XS Max, at that time, that was the first device that offered an eSIM. In Pakistan, at that time, no operator was offering eSIM devices. As part of registration, when a user in Pakistan registers this device, they are subject to paying the custom duties. We found out that initially some entities tried to dodge the system whereby they tried to program one physical slot IMEI of the iPhone with another IMEI slot belonging to a different device. So through GSMA tag database, where we had an idea that there are IMEIs in iPhone XS that offers two slots, one eSIM slot and one physical slot, we were able to segregate, and we immediately mitigated that by identifying that issues. The benefits that we have significantly reduced the number of counterfeit devices, which we categorize them as non-compliant devices. We have helped have better regulatory compliance put in place. The quality of devices that are available in market has improved because now people have access to genuine devices. As I stated, that we have blocked about 3 million duplicated devices and 29 million clone devices so far. Next slide, please. This is a graphical pattern that I wanted to show with everybody, that with the success of implementation of DERBs utilizing the GSMA database, I have posted a graphical pattern whereby before implementation of DERBs in 2019, you can see the blue lines, where on average every year the legal import was around 16 to 18 million devices per year. Ever since we implemented DERBs, that device number increased to 35 million devices per year. So by implementing this system utilizing the GSMA tag database, we have completely stopped the gray channel market in Pakistan. The government revenues from collection of custom duties have increased significantly. There was a delta of around 18-19 million devices that were not being imported through informal channels, but now because the system is in place where user knows that if they do not register their device, it gets blocked. So they are now registering their devices. Because of this, we have created a level playing field in Pakistan, and on top of that, the government has introduced a mobile manufacturing policy that offers great tax incentives. So because of this success, we have now 33 manufacturers who are manufacturing devices within Pakistan. That includes Samsung, Xiaomi, Nokia. So all the big players have come over here. Pakistan has now manufactured over 40 million phones within 2021 and 22 in Pakistan. That has greatly impacted the import bill that the government was footing before that. Secondly, because of this, it has also helped bring affordability for the consumers. When the devices are locally being manufactured, the custom duties are low, and because of that, people have access to quality devices. It has also contributed in bringing foreign direct investment and has created a new industry where over 50,000 employment has been created. Next slide, please. One other thing that a lot of participants over here who are working for maybe the telecom sector or in the regulatory side or the operator side, one thing that we talk about, and even GSMA often does surveys to understand the percentage of smartphone connectivity versus the feature phone connectivity. Now with the implementation of DERB system and the GSMA tag database utilization, in Pakistan, we can give you the absolute number of the smartphones that are connected over there and the absolute number of feature phones. The way we do it is that we are getting the mobile operators reporting us through their data dumps of the total number of IMEIs that are connected there. We immediately run them against the GSMA tag database, and we are able to segregate the smartphone versus the feature phone. So as you can see, in 2018, before implementation of this, the smartphone penetration in Pakistan was around 41%. Now that penetration has increased to 56%, and the 44% 2G or the feature phones that are there. So we have a very good visibility of the total number of devices that are there. That is helping both the regulator and the mobile operators to plan their strategies for introducing new spectrum auctions, the kind of devices that the consumer wants, things like that. So the analytics that we did not have before are there. So it has greatly helped us in that sense. Next slide, please. Key lessons. So looking after the type approval process, the GSMA database has greatly helped us in the type approval process. Our processing time for type approval certification, which used to be about 7 working days, has come down to about 1 to 2 working days for all the SIM IMEI-based devices. We have the GSMA tag database. So anytime a manufacturer applies for a type approval certification, we can immediately identify the IMEI, the tag, and the total associated tag for that particular model and make. At the same time, because of this, we are able to identify fake certificates that have been there. We have had cases prior to us using the GSMA tag database. We did not have this visibility. But since 2019 onwards, we have identified over 100 plus fake certificates. As Tyler informed before, this IMEI help desk email ID is a great way of getting such a verification done. If we have any doubts about a certificate that we feel is photoshopped or forged in some way, we send the scanned copy of that certificate to this email ID, and we normally get a response back within a couple of hours. And through this, we have created a deterrence and a regulatory compliance mechanism through which we are able to ensure that only genuine devices having the GSMA tag registrations are allowed for import and use in Pakistan. In conclusion, GSMA has been a valuable tool for us in improving the quality and the security of mobile devices in Pakistan. We are able to authenticate devices and identify fake certificates. We are able to Pakistan is one of the first countries which has addressed a global counterfeit problem, where we have, I wouldn't say 100%, but we have successfully mitigated about 80% of such cloning, counterfeit, duplicated devices and non-compliant devices, and we have stopped them from connecting to our local networks. That's all. Thank you very much, GSMA, for giving me time. Over to you, Tyler.
All right, thanks so much. Very, very insightful and helpful to showcase the evolution and benefits that the information has provided to the country of Pakistan in addressing those issues. So now I'm going to kind of switch gears a little bit. It's still our device information and status type information, but as it relates to the device information standalone, identifying devices, there's another way and other tools we have to help facilitate what we call the GSMA Device Registry, and commonly referred to as maybe a central EIR. You may have heard it referred to as GSMA block list, the lost and stolen list. There's a lot of different things, but in essence, it's the GSMA Device Registry. So today, the way this works is that we have over about 120 mobile network operators in 42 countries who provide the GSMA with IMEI level data. For example, if a device has been reported as lost or stolen by an end user or by some other entity, or it's been reported as broken or faulty, it was fraudulently obtained, maybe it was a court ordered blocking, that information is passed to us from the network operators who are participating, and we log that information into the device registry service. Now, that device registry service is then taken and shared, across with other mobile network operators globally to ensure that those devices are not enabled or allowed to have access on those networks. Hopefully, with the goal of it making it completely an invaluable asset at that point. The other way that people benefit from this information that's contributed to the device registry is that one of our other services called GSMA Device Check. Device Check's available for lots of third parties, particularly the trading, recycling, repair, insurers, law enforcement sees great benefits in using GSMA Device Check. What GSMA Device Check enables you to do is check this list. So you can input an IMEI, and it will return you with some basic level model details to confirm maybe the device is what you have. And then it also gives you the status of that device. Is that device, has it been reported as lost or stolen? Or is this device, was it fraudulently obtained, et cetera? So right now, the device check service, there's over 250 organizations using this today in more than 50 countries. And the service is being queried, over 100 million times per year. And that number is growing exponentially. And we've seen it grow a lot, I would say 2x, 3x over the past 2 to 3 years. And that's particularly, I think, related to also the increased use of used devices in the market as well. Then you'll see this other list here that we call the general list. And right now we're looking at launching this fully in September of 2023. And this will enable other contributors to provide information to the GSMA device registry. So for example, if I was an insurer, and I'm insuring a device, I would want to make sure that I contribute that data to the device registry system. That way, the device may not have been reported lost or stolen, but you would know that, hey, there's an insurer or a retailer who has claim to that device or ownership at some level to that device, so it shouldn't be marked for sale yet. Or a distributor, or logistics, right? The device is in transit, or in inventory. So there's a lot of different data points that we can add there and provide to make GSMA Device Check even more valuable to the greater ecosystem. Next slide. So here's just an example of kind of what the device check checking history looks like, and this is particularly something that's available to government entities. If other retail entities and things like that, per the policies, we can't always just provide all of the checking history information. But when it comes to government entities, specifically into the law enforcement spaces where they're looking into issues of devices, you can look and see, all right, what is the status when I'm checking this device currently? You'll see there's different lists here that tell you what type of action was taken. Was it an insert, to be blocked, or was it removed? And the reason of that, what type of organization did it, the country that it occurred in, and then this tells you, all right, what's the current status, right? So for this one in red, you'll see, device was just checked. And both the block list status and the G list status indicate that it's a positive, meaning this is a device you do not want to do any business with, or this is a device that's currently not good to transact, or perhaps during a law enforcement investigation, hey, this person stole this device, obviously, that they had on them. Next slide. So another thing I wanted to cover today is around some fraud activity that's becoming more prevalent, which is eSIM fraud, and how we're going to be addressing that now and in the future, because it requires managing and needs to be brought to the forefront of discussion. So in essence, an eSIM or an EUICC makes things easier, right? You don't have to have a physical SIM card. They can be remotely provisioned over the air. An end user can go and purchase a phone that has an eSIM capability. They can do everything from that phone without having to visit a retail location or to wait on a physical SIM card to be issued. So there are companies called eSIM subscription managers that help with this data preparation. There's unique identifiers for every EUICC. And then our forecasting is that, by the end of 2025, there's going to be more than 2.4 billion eSIM enabled smartphones and that are connecting daily. And that currently represents about a third of all smartphone connections. So with the simplicity of eSIM, there obviously becomes a new way for bad actors to do things to create fraud or take advantage of things. And then one of the biggest ones for the eSIM fraud, in essence, is an account takeover or subscription fraud. And that basically is just exploiting the weakness in an eSIM to, enable provisioning and portability. It makes it easier. So that's been captured in this, doing this account takeovers and subscription frauds. In the fraud security manual, we've added that into that section. And then also the process of in and of is blocking a device engaged in eSIM fraud. One of the things about this is that the device IMEI is not always accessible. And that's one of the reasons why it's important to use what we've talked about before this, device check and the device registry services, is that in about 50% or less of all of these SMDP Plus interactions for the eSIM subscription or applying the eSIM subscription, the device IMEI is not passed in that subscription profile. So as a result, you don't always have multiple attributes to check against. So it's important to use both, looking at the eSIM and the SMDP Plus, but also checking those devices against the global list, a status list. So some of the solutions that we're looking at or have identified or are going to be implementing are here on the right. And then I see that we're getting short on time, so I'm going to skip over this last section right here. Let's go to the next slide, please. I want to make sure we give Christian enough time. And perfect. All right, Christian.
Thank you for that, Tyler. Just before we jump into Christian, we've got a little poll for everyone to participate. So hopefully you should see on your screen now a poll. So do read, do press, and then we'll hand over to Christian, who will talk about cities. All right. Cool. Christian, over to you, sir.
All right. Thank you very much, Connor. So good afternoon, everybody. My name is Christian Dressler. I'm working here at Cities in Munich. And before I moved over to Cities 5 years ago, I worked for Siemens after my diploma. And I worked also several years for the German police here in Bavaria in the state criminal police department. And we were starting using the device DB from GSMA middle of 2005. And the IMEI was seen in this age as just a serial number of a mobile phone. And nowadays, we see more and more IMEIs and more IoT devices which consist of IMEIs. Cities was founded in 2017, and we are supporting the German governmental agencies, the authorities, with technical questions. Our main tasks are research and development, support and consulting them in the areas of digital forensic and big data analysis. Next slide, please. Okay, like I mentioned before, in the middle of 2000, the IMEI was just a serial number, and nowadays we can see or we find IMEIs in almost or in many objects in our public life, like vehicles, like many connected devices, e-scooters, special secure phones, and 5G, 4G routers, IP cameras. So IMEI, you can say there are no investigations without we have to deal with the IMEI. The IMEI is more than a serial number now. Next slide, please. Here we can see some examples how we are using the GSMA TAC database or device database. In the first step, when we get emails or TACs from different sources, we check the device, if it is a mobile device or a modem or a router. And then in the next step, we try to assign the TAC or this device, for example, to cars, to vehicles. So that the investigator immediately can see here the IMEI was used in a Mercedes-Benz, BMW, or any other car. The same we are trying to do for secure mobile phones, for all kinds of IoT devices like IP cameras, LTE cameras, e-scooters. This is done in our lab by technical investigations. So we try to find out by using the device DB in a first step more detailed information about the used IoT equipment. All right, next step. Next slide. One of our most effective approach by using the GSMA database is the so-called dual SIM approach. In some cases, we know in investigations, we know the first IMEI of a dual SIM phone, and in some reasons, or for some reasons, it would be important to get the second IMEI, because maybe it might be important for the investigation or for the investigators to do his investigations. On the next slide, I would like to show you how we are using this dual SIM approach in detail. For example, we have an Galaxy S22 here. We know the first IMEI, so we know the first tag value. We are filtering the GSMA device DB by this tag value in the first step. And then we see that this mobile phone has two removable SIM slots, so two removable UUICs. And this is for us, this is the one of the key parameters. As soon as we see that there are two removable UUICs inside, we can also check the model name and the allocation date, which is on the next step. Perfect, thank you. So by allocation date, we found out that when we set now the filter, or we reset the filter to this exactly model name and to the allocation date, we found out that on this specific allocation date, Samsung has allocated more than one tag value at GSMA, which we will see on the next slide, or next step. So on the 29th of March 2022, Samsung has allocated four tag values at the GSMA, and we did this with a lot of examples or a lot of devices, S22 and other Samsung devices, and we found out that always two pairs, the first and the second one, and the third and the fourth one belong to one or the same device. So in this case, we know the tag value of the second IMEI, and for Samsung devices, we keep the last 6 digits unchanged, take them from the first IMEI to the second IMEI, and so we have the complete IMEI for this phone, for this dual SIM phone. This scheme works for several or a lot of mobile phone suppliers. We found out some other schemes, some numbering schemes for IMEIs, which is a very effective and very smart example to use the GSMA database and filter by special key values, and found out very, very important data for the investigators. All right, so this is some examples for it. It's the end of my presentation, and then I hand over back to Connor. Thank you. Okay, here we can see our, just one slide, sorry, Connor. This is our service we are going to build or develop for the customers, for our customers, which in basic has the entries from the tech database, and we add here some more information which we found out during our investigations, and we will hand over or give this to our customers, to the German security agencies. So, sorry, thank you.
Brilliant. Thank you for that, Christian. And thank you to Tyler and Newman for their time and effort. I'm sure anyone who's been involved in these type of events will appreciate the amount of coordination it takes. But hopefully everyone found that of interest and relevance. What I wanted to do now is just take advantage of the time we have left. Firstly, see if you can answer the poll that's just popped up. Would you like to speak with GSMA representatives about anything you've heard today? And if so, what you'd like? The other thing is both Newman and Christian have also agreed to speak directly with anyone who's joined the call, should you have some specific questions related to your organization or theirs. So thank you both for that, gents. So what I'm going to do is go through the questions now. If anyone else has any more questions, please do put them in the Q&A piece at the top. I'm going to group a few of them together because there's a few duplicates or just commonality. First is about duplicates IMEIs within devices. People have seen this within the market. Tyler, do you want to talk about how we identify those and how do we address those as such?
Yeah, so I mean, obviously we rely on the market to send those back. A lot of the contributing mobile network operators in the countries I mentioned, 120 plus operators, they actually will report duplicate IMEIs to us that they see on their network, and we provide that information in our device registry and device check. So for example, if you query a device IMEI on device check, part of the information you get back is whether that device has been reported as having a duplicate IMEI or whether that IMEI has been reported as being duplicate. So you can identify it through one of our services as well to help address those issues. I think the other piece is the more and more the GSMA data is used globally through government entities specifically, and taking action on device homologation and the proper approval processes before they're coming in and being allowed in the country or on networks. That helps address the need or the desire of nefarious actors in the market to create these cloned or duplicate IMEIs. Yeah, so I think that answers the question pretty well.
It does. Thank you, Tyler. Sharing information and also leveraging the tools we have. So thank you for that. Actually, whilst I got you, Tyler, obviously the focus has been on mobile phones, but in terms of TAC and device identification, can we identify other types of devices?
Yeah, so with the TAC, obviously, it's required. The reason anybody gets a TAC is because their device that they're creating is going to be connecting to the mobile wireless network. It doesn't matter what wireless network it's going to connect to. If it's going to connect to a 3GPP standard type network, or even the old CDMA type data, then they're going to get a TAC. So that includes things such as smart meters that may use, it's considered an IoT, or security type cameras that are connecting through an IoT model. That includes all of your mobile or wearable fitness trackers, watches that have the ability, the ones that don't connect to the wireless network that, are Bluetooth only or something, they obviously aren't required to have a TAC. But all the other ones that do connect to a mobile wireless network are required to have a TAC. So it's not just looking at mobile devices in the traditional sense of a smartphone or a feature phone. It's everything in between and expanding daily, and that the more things in our lives are being more and more connected to the wireless network providers.
Brilliant. Thank you for that, Tyler. I've got a couple of questions in relation to DIRBS. Are roaming charge devices subject to DIRBS processes? And then the other one, which is an expansion of that, is how has implementation of DIRBS using GSMA device database contributed towards development of telecom sector within Pakistan? So I don't, Newman, do you want to talk about those?
Yeah, please. Okay. First of all the roaming devices are exempted from this process. We don't want to create any disruption for such roamers. They are connected for a very short time period. So all the roamer devices are bypassed by this DIRB system. We do not engage with that at all. Your second question, how this DIRBS has contributed. It has created a level playing field for the local importers and the manufacturers in Pakistan, because they do not have to fight, or they do not have to compete against the gray market channels. And because of that, they have a very good business environment and a level playing field. For consumers, it has given them this confidence where they can query and check the status of an IMEI to make sure that this IMEI is a genuine device. It's not a duplicate or a clone device. As a regulator, it has given us analytics and a regulatory control through which we can get compliance, and improve the market and the ecosystem over here.
Brilliant. Thank you, Niam. Probably one for Christian. What advantages does ZITIS bring to German architecture, security architecture?
Oh, well, yeah, as a central service provider for the federal authorities with security tasks, we can spend almost 100% of our time to develop and research innovative technical solutions, tools, and also methods that contribute to maintaining internal security in Germany. So we are not involved in any investigations. We can absolutely focus on developing and research innovative technical solutions. That's the main advantage, I think.
Brilliant. And then how often do you use the GSMA tech database? Is it weekly, monthly, yearly?
Yeah, we almost let's say we get every week we get several requests from the federal authorities regarding IMEI or tax of smartphones, of IoT devices, of all kind of vehicles and more. So that's why we decided to ask for the official service provider level of the GSMA service, and we will provide this service with additional information to our clients, which are all German federal security authorities.
Brilliant. Thank you, Christian. I'm going to finish up soon, but before doing so, does anyone want to go on camera and ask a question or ask in the chat at all? No? Okay. Well, the good thing is we're here and available throughout this week, this month, this year. So please, if you have any questions afterwards, please do come to us. But with that, I'd like to thank everyone for giving up their time, which is very valuable today. So firstly, thank you to all the speakers and all the people who have helped set up this event, but also thank you for all the attendees. I really hope you found this session of value. There will be a copy of it available afterwards. But yes, hopefully we can collectively reduce crime, reduce fraud, and make a better world. So with that, I'd like to thank you, everybody. Have a great day, morning, evening, wherever you are, and take care and be safe. Take care all.